Hello, everybody. This company is mixing autonomy, SLAM and LiDAR algorithms with really cool UAV tech to enter the future of beyond visual line of sight mapping, real-time scanning, and smart navigation. Yes, all that in a drone. Let me introduce Emesent. Hello, everybody, and welcome to another episode of Builder Nation. I'm your host, Sam, and today we are joined by Stefan Hrabar, CEO and co-founder at Emesent. Welcome, Stefan. Thank you very much for joining us today. Could you please introduce yourself a little bit?
Yeah, sure. Thanks, Sam, and thanks for the invitation to be on the podcast. It's a pleasure to be here. As you mentioned, I'm Stefan, CEO and co-founder of Emesent. Emesent, we're a robotics, autonomy, and analytics company based in Brisbane, Australia. Our vision is a world where there's no space beyond human understanding, and we're enabling that through our mission of empowering industries with autonomous mapping and insights. So as you alluded to, we're basically using the combination of SLAM, LiDAR, based mapping and autonomy to allow drones to fly into challenging GPS-denied places beyond line of sight.
Thank you very much for that quick intro. Honestly, it is. I'm really excited to really dive deeper into this. As you people can see in the background of Stefan's image, he is sort of like in a cave. We're gonna talk about that because if I'm not wrong, that is like an actual application for your drones. I want to jump into that, but in a minute. First of all, I would like to ask you if you can give us an overview of what Emesent does. Like you already mentioned, you build these drones, and these drones have a really advanced software, pretty much, and hardware components for scanning and mapping. But what does Emesent does? Like the whole idea of your company.
Yeah, no. Basically, like I said, we're more of a software than a hardware company. So our background's really in robotics and autonomy. So that's my background as a PhD in robotics. And my thesis topic was vision-based navigation for drones. This is more than 20 years ago, trying to get drones to fly in challenging environments back then using cameras or vision. And then obviously putting all that compute power on board to process in real time and allow that sort of autonomous navigation. That evolved through my time, through my PhD, and then I moved to Australia and joined the CSIRO, which is the National Research Lab in Australia. Had a very strong robotics group that were doing sort of autonomous systems in mining and other industries, and they'd started up a drone program. So joined that program and continued the same line of work. Started using LiDAR on drone as well to do navigation, but it was all still above ground using GPS. And then at the same time, we had another group in that robotics program who started working on SLAM-based LiDAR, originally for ground-based navigation. And then obviously we saw the benefits of kind of combining the two and doing SLAM-based navigation on a drone using LiDAR, which opened up sort of new opportunities. So that's still the core of what we do. So we have a large software and robotics team that work on the algorithm side of things, the full autonomy stack. We have hardware engineers doing mechatronics and electronics and the hardware design. Is not the full drone. It's actually, so if you see which side is it? The side, the picture of the drone behind me. The bit hanging underneath the drone is actually the hardware we produce. So that's our LiDAR mapping and autonomy payload called Hovermap. I've actually got one with me. I don't know if it'll show up well in the with the background, but yeah. So this is a Hovermap payload. Got the LiDAR in the front, and then this is the bit that basically attaches to the drone. Everything is on board here, all that sort of compute power running the full autonomy stack, and it's designed to be a plug and play, connected to the drone, and use it as a LiDAR mapping and autonomy payload. What else? So yeah, and then obviously there's the data capture while the drone's flying. All of that sort of LiDAR data is stored on board. Then there's a post-processing step to run our SLAM algorithm over the data in a more sort of optimized way, in a way that's optimized for accuracy. And what's produced is a 3D point cloud in standard industry standard formats like LAZ, LAS, and that point cloud is then used in different ways by different applications in different industries.
Thank you very much for that. I mean, these generated a bunch of questions for me. I also want to delve a little deeper into what you mentioned about this plug and play solution. But first, let's step it back just a little bit. For anybody who might not be familiar with it, could you explain in general terms what this SLAM and LiDAR technology is and how that works in a drone for mapping?
Yeah, sure. I mean, obviously I'm used to the terms, but not everybody is. So LiDAR is basically light detection and ranging. So it's similar to radar, but it's using laser pulses. So the device is sending out a pulse of laser light that's bouncing off something and being received, and then using sort of knowing the speed of light and the timing information, you can figure out how far that thing was. So we don't build the actual LiDAR puck that's off the shelf, but we use the data coming from that device. And the ones we use produce, in one case, more than 1 million pulses per second. So we've got, millions of LiDAR pulses going off in all directions, because we do rotate that puck while the system's active, and that gives us a full spherical field of view. So taking all that data in real time and then running the SLAM algorithm over that, and SLAM stands for simultaneous localization and mapping. And that's a concept pretty widely used in robotics. Even your iPhone has SLAM and LiDAR built on board these days. But in the early days of robotics, it was kind of, there's a challenge where if you're sending a robot into a place it's never seen before, it needs to try and localize. So it needs to recognize where it is in relation to a map. And then once it's done that, it needs to be able to continuously kind of add to that map and build the map. So it's a bit of a chicken and egg problem. You can't localize if you don't have a map, and you can't map if you can't localize. So SLAM solves that in an iterative way. You build a small map, you move, and this is happening continuously, but you're building these kind of small snapshots of maps and then looking at them and comparing them to identify unique features that can be recognized in each of those little snapshots. And by that, you can basically work out how you would have moved relative to those features. So that's how you build up your trajectory or your path. And once you build up your path, you can then project all those points back out to a common coordinate frame, generate the map. So yeah, at a very high level, that's what SLAM and LiDAR are.
Right. I mean, it's honestly amazing to learn it. Thank you very much for that. Now, I have a bunch of questions, but I feel it's a good idea to start with the beginning of how did the Hovermap come to be, right? I mean, you already mentioned it yourself. You have a lot of experience, in robotics and mechanical engineering. Like, that's literally what you studied, and you have a PhD and everything. Well, you have a master's. How did the Hovermap idea come to be born? Because this seems like a very, very niche industry and a very niche market for the Hovermap. So how was it?
Yeah, I guess a couple of things led to that. Like I said, we'd been doing autonomy and sensing and on drones, but using cameras, and then we did start using LiDAR. But obviously, when you're working with a drone, weight is critical. Size and weight are critical. So back, when we first started, when I joined CSRO in 2006, it was, there wasn't really an off-the-shelf LiDAR that was suitable to be used on a drone. They were all sort of big, heavy things.
Right.
So a few years later, a smaller device did come on the market from Hokuyo, but that had a single scan plane. So if you wanted to use that, either had to mount it horizontally, and then you could see a slice through the world in the horizontal plane, in the vertical plane, or sometimes we mounted it horizontally, and then you couldn't see up or down; you could just see straight in front. So it had sort of some sort of use, but wasn't really great because you didn't have a wide field of view. So what we started doing is basically actuating that device and rotating it to give it the third dimension. So we had a very, very early prototype using this smaller, lightweight LiDAR, but had a limited range and limited sort of resolution, but it was still good enough. So our first prototype actually used that LiDAR, and we proved out the concept that you could use rotating LiDAR on a drone, run all the processing in real time with SLAM to do some basic navigation. But fortunately, soon, within I think a year or so after that, other LiDAR devices hit the market, like the Velodyne VLP-16, which was really a game changer back then in terms of what you could get for that size and weight. 100-meter range, 16 scan planes. So that really opened up new applications. So yeah, the question was, how did Hovermap come to? Yes, it was, we were looking for a sensor that could give 360 field of view for a drone and provide detailed maps at the same time. and LiDAR kind of met those requirements. Obviously, there's other options. You can use cameras or vision-based techniques,
Right.
and those have advantages in terms of size and weight. You still need pretty significant compute power to process the imagery. The cost is lower as well, but there are sort of challenges with lighting conditions. So if you're flying in dark areas, like we often send drones with Hovermap, then it can be a challenge for a vision-based system. So
Right.
yeah, those kind of technologies came together, and I realized there was a benefit in having a plug and play payload, because at the end of the day, the drone is just something to carry the sensor payload. So you often might want to take the payload off the drone, switch it out between drones, or actually use it as a device off the drone. And that's another way that Hovermap is used, is you can take it off the drone, you can walk around with as a handheld mapping scanning device, or you can mount it on other vehicles, like we've integrated with the Boston Dynamics Spot robot. And yeah, so it makes it versatile. You can kind of attach it to anything and go mapping.
That's actually pretty cool. I didn't really know that was a thing. It was possible. But I mean, I did, for example, see that in your website you sort of have these Boston Dynamics robot, like within the office or something. It was pretty cool. It was pretty cool. So thank you very much for sharing that with us. I do have sort of a follow-up question with this. You already mentioned that this is a very plug-and-play device, but you can also take it off drone. This means that it has to have, first of all, an internal battery, and second, an internal method of emitting this data, right? For it to be, for it to build the mapping and everything like in real time. Yeah. So how did you actually come to develop this technology, and how autonomous can it really be? How long can it actually work? Can it fit any drone? Like, how is this plug and play solution by itself?
So just to clarify, we don't have an internal battery. Again, it's a trade-off with weight on a drone. Drones have their own battery, so the idea is once it's connected to a drone, we basically tap power off from the drone battery, and we don't have to add extra weight with the battery and Hovermap. And then when it's used off the drone, then it's very easy to attach a external battery. So that makes it a bit more versatile. So how we integrate with drones, obviously, when we're doing the autonomy, we're actually taking full control of the drone. So we have to interface with the flight controller or the autopilot. So what Hovermap's doing internally is running a full autonomy stack down to a fairly low level. So we basically send attitude angles as commands to the drone and yaw rate. So we're not just giving it a waypoint and letting the drone's autopilot fly to that waypoint. We're actually saying tilt forward at 2 degrees, and that's how we control the drone. So that's all happening on board in real time, and there's different ways that the drone integration. So we started off in being compatible with DJI sort of enterprise level drones. Back in the day, it was the M600, and then the M210. In the M300 now, and now the M350 as well. So we integrate through their API. They've got basically a way that you can connect in and talk to the DJI flight controller. And obviously we're sending commands, but we're also reading a lot of data from the flight controller, battery health, battery status, any fail safes, GPS connections, etc. And like I said, we take over full control. So we're doing all the fail safes, for example. If there's a return to home, that's all handled by Hovermap. And we had to do that because obviously, the system's designed to fly in GPS denied environments. So a typical DJI fail safe would be climb to an altitude and come home. If you don't have GPS, or if you're underground, that's not a good idea. So we've had to obviously think about all those scenarios and cases where there's a return to home and how that can be triggered. So in terms of integration, I started with DJI. We have integrated with other drones now, so we're compatible with the Pixel Cube, which is part of obviously many drones, and we're integrating with a few drones that use that and some other autopilots. And now that we've done it once, it's obviously a bit easier to do. There's some small changes for individual drones,
Right, just
and
adapt
obviously
them.
there's the mechanical mount as well. So we do have sort of our custom dovetail mount with a mating plate that can be attached to different drones to allow that integration. You had a question about the autonomy and how the autonomy actually works. So we have basically 3 modes. Our sort of one mode is actually zero autonomy, so it's just used as a mapping payload.
Okay.
You attach it to the drone, you fly it as usual with the sticks, or plan a GPS waypoint mission if you're above ground, and just let the drone do the flying, and Hovermap is just collecting the mapping data. So that's one option.
Right.
The other option is what we call our pilot assist mode. And in that way, Hovermap's basically making it easier to fly the drone and safer in GPS denied environments. So it's we used line of sight, so when the pilot can see the drone, still using the RC controls with the joystick, and Hovermap's basically forming a virtual bubble around the drone and giving you position, hold, or velocity control without GPS. So if you're flying underground, you can take your hands off the sticks and it will keep in a very stable hover. Or if you're flying around underneath a bridge to do a bridge inspection, Hovermap's keeping the drone safe and not letting you get too close to that infrastructure, and just making it easier for the pilot. And then the next level is our fully autonomous, beyond line of sight, beyond comms range capability. And in that mode, basically we have a tablet interface. Hovermap is streaming a real-time point cloud to the tablet when there is a link. So obviously when it's near enough, we have a link. Stream the point cloud, and you can view that in 3D. And then to set basically a task or a mission, you set waypoints in that 3D map just by placing them in the map. And often those waypoints will be way beyond where the current map can see. So if you sort of want to fly down a tunnel underground in a mine, you'll see the beginning of the tunnel, and you'll place a waypoint somewhere, maybe a few hundred meters down the tunnel, to give it a guide of like approximately where you want it to go. But obviously you might not know exactly what the shape of that tunnel is. So set a waypoint somewhere in the distance, press go, and then the system is autonomous. So it's navigating with the LiDAR, it's looking for obstacles, we can detect very thin wires and other obstacles. It will do its best to try and reach the waypoint. If it can't, if the waypoint's actually placed in the middle of the rock somewhere, obviously it'll try its best. Eventually it will time out, give up. And if there is another waypoint in the sequence, it'll then move on to the next waypoint, or else it will return to home. Or if the battery's getting low, it will return to home. So it's always building up this map, and it will figure out how to get back. And then once it obviously can do that beyond comms range. So this is assuming there's no comms range. It'll still continue on the mission. Once it gets back to within comms range, it will stream all that data that it's been collecting, or a low-res version of the data. So on the tablet, you can see where it's been, if there are any spots that were missed, and then you could retask it and send it out to explore further. So that's sort of the 3 modes that we've released commercially. And then what we've been using in other scenarios is our autonomous exploration mode. And that's something we'll be releasing as well. And in that mode, you don't set any waypoints. You just basically say, go explore, and it figures out where it hasn't been before. So it'll go flying like in a cavern, like you see behind me. It would just explore that by itself.
That's very, very cool. And I mean, this definitely versed many questions to me, right? So I would like to keep it, first of all, in an order. Number one, and this is something that I'm genuinely curious about, how long did it actually take to develop such a well-rounded product? Like, I mean, I understand that the software part is probably the most time-taking part of it, because in the hardware side, you don't mention that this is technology that was already there. You didn't create anything new in the sense of you didn't create LiDAR or SLAM, but you definitely did merge them together, right? So how long did it take, or how many iterations of the Hovermap did it take to actually get to where you are today, such a well-rounded product?
Yeah, I mean, obviously it goes back a while. I mean, the work that was done before Hovermap kind of led up to this. So the groundwork that we did in sort of autonomy and navigation fed into the background of this. So like I said, I was working at CSIRO for 13 years before founding Emesent. It was around 2014 when we sort of started with the first prototype and concept of Hovermap itself, so using LiDAR and SLAM, and that continued for obviously a number of years while we were still inside Cyro, developing hardware prototypes and evolving the software. And then we spun out of Cyro at the end of 2018. So it's been nearly 5 years now that we've been out as Emesent. During that sort of development, we went through obviously a number of prototypes on the hardware side. So I think we went at least 3 or 4 kind of 3D printed prototypes. At one point, we had around 20 early adopters in industry using those 3D printed prototypes, and we were getting their feedback and understanding, where it would fail and the different use cases. And then as we spun out, soon after that, we'd been working on the first commercial version, and it was, I think, a few months after we actually spun out of CSIRO, we had the first commercial version launched. And then since then, we've been through 2 more iterations. One sort of in the next iteration was from the Hovermap 100 to the Hovermap ST, like I showed you. Total redesign from the hardware side of things, using the same LiDAR. The new design is just lighter, smaller, better IP rating, higher sort of range of temperatures, etc. And then recently released our STX model, which is the same as the ST, except the LiDAR is different. So that's kind of the 3rd iteration.
All right.
So to answer your question, many years, yeah.
Yeah, I mean, it is kind of where I wanted to go, definitely. But it also verges another question, which is, how did you actually find this product market fit for this technology? How long did it take? And you already mentioned you had some early adopters. How long was it actually for this to find its place in this?
Pretty quickly, actually. The challenge, I think, was more about where to focus. So there were so many different ways it could be used in different industries. Yeah, I mean, looking back, it was, like I said, we started around 2014 with the concept of Hovermap. And then I think it was the same year I was approached by a mining surveyor who somehow heard about what we were developing. It was, we were nowhere ready to go and fly in a mine yet, but he sort of heard that we were putting LiDAR on a drone and could potentially fly into some of these areas. So he reached out and explained to me the sort of current challenges they had around mapping of stopes. So a stope is basically kind of similar to what you see behind me. That's not really a stope, but it's a hole in the ground, deep underground, that's been formed by blasting and then removing the sort of the blasted material. Forms a void, that's called a stope. Surveyors need to go and map those stopes to make sure that the blast has gone according to the plan, because obviously they're trying to extract the high grade ore and leave the low grade stuff behind. So they have to scan it and assess whether they've sort of extracted the right material and not anything else, or there's no so anyway, they were going to these voids underground, getting dangerously close to the edge of these kind of underground cliffs, taking a laser scanner on a pole and poking it in there to try and scan it. And obviously, because they're only viewing it from one point of view, they don't get a full picture of the stope. So it's dangerous, time consuming, not good data. So he came to me and said, "Hey, could you fly a drone in here?" And we said, like, "Yeah, sure, maybe one day." So I then carried on with the development. And then when we had our early adopters, we didn't go straight to mining because we didn't have the autonomy capability ready yet. So we were looking at things like mapping cell phone towers. And we had quite a strong sort of use case there. Again, using the autonomy to keep the drone safe while it's flying around the tower, capturing LiDAR data, capturing images, used for sort of general survey tool, mapping bridges, mapping forests. So a whole bunch of different use cases. But then once we had the full autonomy capability and we could really actually go and fly in a mine, as soon as we flew into that first stope and the surveyor saw the result, it was kind of like, yeah, this is it. This is the game changer. They were just blown away by the data and the potential for it. So that's when we realized it was a good idea to focus on mining. That's very challenging environment. We've solved kind of a challenging problem in a unique way. And yeah, so it kind of went from there.
I mean, it does sound like it was a very game changer, specifically for the mining industry. And I want to touch the case studies right here. But before that, I want to make a quick comment to the viewers that currently have over here. First of all, don't forget to like and subscribe, of course, right? But also feel free to leave any comments or questions for Stefan over here in the chat. I believe that it's going to be really cool for us to get different insights. But before those comments arrive and everything, I want to really go into this side that I mentioned of the case studies. Like you already mentioned,
Mhm.
the game changer sort of application for these was when you got to mining, right? Because it's definitely a very dangerous industry, of course, for especially for scanning, mapping, and everything. But originally, how? Let me phrase this very specifically. How did the hovercraft, did the hovermap find its way into these harshest environments? Like you mentioned it, you started off by scanning and mapping very, first of all, very safe areas, maybe bridges and stuff, right? Like with a lot of room for this to maneuver. How did it find itself the space into these minings? After this first use was applied, after this person that company that approached you finally
Yeah,
figured it
yeah.
out.
I mean, that was still while we were part of CSIRO, the research organization. So we weren't a commercial company yet. We didn't have a marketing team, etc. So it was kind of word of mouth originally, us going out directly speaking to mining companies. We went through an accelerator as well. So we had a 3-month accelerator period while we were part of CSIRO, and that was where I didn't have a business background, so that's where I
Right.
obviously went from sort of researcher scientist to learning about what a business model canvas is and how to go to market.
It's quite
and
the
all
shift.
these,
Yeah.
yeah. But I mean, the main message from that whole accelerator was kind of get out the building and speak to customers. So that's what we did. I mean, we'd sort of call up customers, hear about their problems, and obviously in the mining space, as we started understanding the challenges that they had, and that we had a natural fit and a way to solve it.
Absolutely.
Yeah, we sort of engaged with more mining. CSIRO as a research organization actually has a long history of working in the mining industry as well. So
Yes.
that develops very advanced mining automation solutions over many years. So we had some good sort of connections there as well. And obviously, fortunately, we are in Australia where mining is a huge part of the industry, sort of economy here. So we were lucky that we were in a place where mining is important.
Yes.
I think if we'd been in the Bay Area, obviously it would have been a bit harder for us to go and speak to mining customers. But then, once we spun out and left CSIRO and formed Emesent, obviously we developed a sales team, a marketing team, got our go-to-market sort of in line, and obviously went to market through all the traditional methods, trade shows and conferences and online. I think fortunately for us, the visuals that are created by Hovermap are stunning. I mean, they're very interesting to look at the point clouds. So I think that's really helped as well. Put up a video on YouTube or LinkedIn of point clouds, and people just love it. So it helps to have eye candy when you're trying to promote your product.
I definitely agree with that. I did actually watch some of these videos and images myself. They are amazing. It's very futuristic. It is really, really futuristic, which is very cool. Now, I have also one other question regarding these use cases. This is just my own curiosity. What is, to your knowledge, and if you can actually share this, what is one of the most maybe extreme or maybe sort of more dangerous, if you will, applications that the Hovermap has been used for? If, of course, that's something you can answer.
Yeah, I mean, I guess it's used every day in pretty crazy extreme examples, and we don't get to see most of them because our customers are sending drones into these places. But I mean, definitely many that I've been involved in and that I've seen, and we've developed case studies in combination with our customers. I mean, to me, one of the most nerve-wracking mine trials I went on was the first time we actually tested the waypoint-based beyond line of sight autonomy underground in a mine. So this is 2016, I think, and we were still flying on a prototype 3D printed hardware on an M600 drone. So it's a big drone
Okay. Yeah.
underground in a mine. And they had a very unique problem where there was a very massive stope. So usually these stopes are, maybe 40 meters. The stope was
Okay.
over 100 meters wide and 60, 70 meters in height, and they had no way of getting data in this area because it was so big. So we sort of said, we'll take a risk, we'll send in the drone, and so we did. We sent it off, and I mean the stope is so big and dark that once the drone's gone, sort of around the corner, you can't see it anymore, you can't hear it, so everything just goes
Yeah.
dead silence. It's pitch black, and like every now and then you hear a little faint bit of the props moving.
Yeah.
And then like 10 minutes later, you see some lights, and then this thing's popped up and it came back out again. So it's like, thank goodness it's come back home. And the results were incredible. And then other use cases. I mean, for example, one of our customers in Sweden used it to inspect a hydro power station tunnel. So obviously they've got these basically
Ooh,
like
wow.
mine tunnels through the mountain that the water flows through to the
Right.
turbines, and occasionally they need to inspect those, so shut down the turbines, and obviously that's a very dangerous area as well. I mean, they don't know what's in there, so and there actually had been a blockage, so there'd been a blockage in one of these areas. They didn't know where it was, so they
Oh.
sent the drone in autonomously, and a similar situation. It goes in, and before long, you can't see it, you can't hear it, you've got no idea where it's going, what it's doing, and you're just kind of sitting there waiting, hoping that it's gonna come back. And it did come back a few minutes later and gave them perfect data. They could figure out what had happened and sort of how to resolve that.
Wow. I'm mind blown. This is genuinely incredible. Not just that you already sort of experienced that feeling of like what you shared, right? That first time of actually letting the drone go by itself and stuff. Like I personally fly a couple. I have flown a couple drones for pictures and stuff, and it is definitely like a moment where you don't see it. It's not recommended for anybody. But it's amazing to see that has already been so effective, as in the case in Sweden you mentioned. Now, I have a different question regarding the applications here, in more of a sort of in the open space, right? There has been use cases for these for maybe public safety, right? For the Hovermap. Are there actually plans, maybe for example, to use this, or is it possible to use the Hovermap, for example, off the top of my head, as a first response sort of aid, maybe for natural disasters, maybe for I don't know, things like this, right? Situations where it might be very difficult to actually go and explore the area, or the damaged area, or maybe it was an earthquake or something. Is it something that it work?
Yeah, absolutely. I mean, that's another industry I haven't even talked about yet. So it's sort of defense and public safety is a new vertical that we're engaging in over the last kind of 18 months and getting some good traction there. Obviously, similar challenges, right? There are many places that are hard to reach, challenging environments, dangerous, they don't want to send people in. And obviously robotics are perfectly suited to helping in those environments. And because of Hovermap's versatility, it can be used on a drone. And it has. I mean, there was a parking garage collapse a few months ago in New York City. I don't know if it was obviously on the news. So after that collapse, unfortunately, it was just a few weeks before we'd done a demo to FDNY. So they were aware of Hovermap, looking to come on board as a customer. So they called in our team to come and help them scan that environment, because it was a very hazardous, challenging environment. Multiple floors of a parking structure had collapsed. I think there was one fatality. And the buildings adjacent to that parking structure obviously were jeopardized because they were kind of right next to all this rubble. So we flew in with Hovermap over the top, did some handheld scanning around the base, and they could use that 3D data to try and assess, how stable those structures were and how they could basically try and pull things apart and recover. And so used in that case, and also in the mining industry, it's been used numerous times for search and rescue. Unfortunately, sometimes it's become a kind of more of a recovery effort than a rescue effort. But they have obviously mining is a dangerous area, and there are fatalities. But in those cases where there's been a collapse and something's happened, being able to send in a robotic autonomous system to figure out what's happened and how, is it still too dangerous to send people in? Can save vital minutes when you're trying to assess, like, is it possible to go and rescue somebody? And then, with the integration with the Boston Dynamics Spot, I mean, that opens up a whole new area of kind of first responder search and rescue applications as well. Because obviously a drone is not always the right tool to go. And like if there's been a collapse, you're not going to fly a drone in through tiny little sort of gaps, etc. So that's why we're integrating with Spot as well for kind of that's first responder kind of applications. And the great thing with that as well, Spot can carry other sensors. So we can carry gas sensors, microphones, cameras. So Hovermap provides kind of the advanced autonomy, allowing Spot to explore areas that is not possible kind of just by joysticking Spot or using like the off-the-shelf Boston Dynamics kind of capabilities. So it's providing that autonomy and capturing the LiDAR data. And if we've got other sensors on board, we can synchronize all that data and overlay gas readings or images over the 3D point cloud, which gives you sort of a multi-sensor, multimodal view of the world.
It's amazing to know that. I mean, I honestly didn't expect that it was already a use. This was more of a question where I expected if it was in the future going to be used. It's amazing to know that this is it's a vertical you're already exploring. Thank you very much for sharing that. Now, I also have another question that relates to this. Now, all of the hover maps are IP65 weather sealed, right? So basically, they resist quite a bit of water, quite a bit of environments. But are there maybe any use cases where you have seen that there may need to be some modifications done to the hover map, maybe for it to withstand maybe a little more extreme or more harsh environments, or perhaps more, I don't know, regarding gas or weather or smoke, etc.?
And we kind of solve that problem with our accessories. So, Hovermap's kind of the core, think of it as the GoPro, and then you get all the GoPro accessories. So we've got the equivalent. So if it's mounted on an underground vehicle, then we have more of a kind of a magnet mount or a suction cup mount with a protective cage that you can just stick it onto a vehicle and use the vehicle to go and scan. Obviously, when it's on Spot, we have a similar thing. We have a protective cage that sort of bolts onto Spot, and then Hovermap just sort of plug and play in and out of that protective cage. Another way of using it is in vertical shafts in mining and other industries. So some of these shafts can be hundreds of meters deep, used for ventilation to ventilate the mine, and they need to be inspected. So not always practical to fly a drone down these shafts just because of the size of them, the length of them. So, many mines are already using a winch with a cable lowering down a camera or anything that they could to try and inspect these very long shafts. So now they've just attached Hovermap to the end of the cable. We've got a protective cage that protects Hovermap from any rocks that might be falling or water, and they can use that to scan the vertical shaft. So I guess by these different accessories, you can get Hovermap into different places. Even something simple like a telescoping pole, like a painter's pole. You attach Hovermap to the end, and if you want to poke it into like a small space or through an opening, it just makes it easier to do that.
I mean, I didn't even expect to hear so many potential applications, or I guess real applications already been verged. This triggers a really interesting question. As an engineer, as engineers, we pretty much try to solve the problems that come to our face, right? So all of these modules and accessories and everything, were they sort of a response to a use case a customer needed, or were they more about maybe developed as a hey, wouldn't it be cool if the Hovermap could withstand this specific use case? How did they come to happen?
I'd say it's a bit of a mix. Obviously, we've got very imaginative engineers with great ideas, and we're always thinking up like cool ideas. Wouldn't it be cool if we could do this? But we've obviously got to balance that with the commercial sort of reality and commercial potential. So we have now we have a very sort of thorough and detailed product management function and process about evaluating what do we build next, and what the priorities are, and what's the market size. So sometimes we have to kind of resist the urge to do something that might seem really cool, but maybe hasn't got a big commercial potential. But yeah, most of those accessories that I mentioned are a result of customer demand. So a customer wants to use Hovermap to go and do X, and then we think about like what's the best way of enabling them to do that. So we'll develop an accessory, but obviously always with an eye for like how else can this be used. We don't want to just sort of develop an accessory that's very niche focused, can only be used in one way. And then we also have many customers who just do it themselves. It's been amazing to see how customers have adapted Hovermap and mounted it to different things in different ways to scan different areas. We've got. I wish I could get a collection of all the sort of amazing really cool things that customers have built to mount their Hovermap to and use it in different ways. They get very creative, which is great.
That's actually amazing. It's also really cool how modular this is. Not necessarily for in-house modules, like for the ones that you build, but also for these customers, which is actually pretty cool. But now this triggers a question where I want to poke your CEO brain in this part, not necessarily the engineering side, right? So you build a Hovermap and you build all of the modules, and then you do a lot of research and development. I assume that is very, very active, both in software and hardware, right? So I have a question. I really need to know this. How do you as a CEO keep track and keep maybe procurement and supply chain and everything really, really tight and in place? Because especially the larger a company grows, like Emesent is really exploding, which is amazing to see. So does payments and buyings and inventory and stuff. How do you keep track of all this?
I don't. No, just kidding. No, with help. I definitely, that's way beyond my sort of expertise, and so I just bring in experts. So we've very early on we kind of grew the team with expertise that we needed. We've got heads of departments that are sort of experts in all those areas. So yeah, it helps for me to have a high level overview of kind of what they're doing and what the priorities are and what the challenges are. But really sort of trust in our team to handle the day-to-day operations of the company. So yeah, I feel in the very early days, yes, I had to do a lot of that myself, together with Farid, my co-founder, and we were kind of doing everything. But yeah, as soon as we could, we brought in the right expertise to handle those functions.
Right. I have to say that was the most CEO answer ever, which is, it's amazing. Thank you very much for that. Now, I want to go back into this mixture of your CEO and engineering brain, right? Now, the term mapping the inaccessible, it's pretty much your slogan or your motto or your mantra or whatever you choose to call it. Mapping the inaccessible. Can you please elaborate a little on this philosophy, yes, and how it really leads Emesent's innovations?
Yeah, I guess we want to focus on applications where we have a UVP or unique value proposition and a strong moat, I guess, around us. So that's why we focus on solving the challenging problems. Obviously there are many other drone-based LiDAR systems on the market that use GPS and INS, so you can fly above ground and map very large areas. Where autonomy is not important or not critical. So if you're flying high enough, you're assuming no obstacles, you assume you've got GPS. Likewise, in the mobile mapping space, there are other providers out there that have SLAM-based mobile mapping systems, sort of handheld devices. But they again assume that somebody's going to go to the area themselves. So for us, because of our core kind of capability in drone autonomy and now spot autonomy as well, and SLAM-based mapping, it's just made sense for us to focus on the areas where we can make a unique difference. And I think to me and to our engineers and team, it's actually more exciting and stimulating to work on the hard problems, the challenging problem of this sort of GPS denied environment. And yeah, it's obviously the markets we're looking at a high value problem. So a lot of benefits, and yeah, I guess like I said, for me personally, it's been more interesting working on areas where I know there's a real challenge, and something is hard to solve, and we found a way of solving that.
I mean, that's actually a very, very interesting way of putting it. Thank you very much for that. But this triggers a very, very specific question. Is it maybe in the plans for the future, perhaps, or is it already maybe in the works? I don't know. Mapping some of the maybe even more inaccessible places, which in this case we're talking about maybe underwater. We know that exploring the sea is actually something that is right now not just popular but also very dangerous. So
Yeah.
I can see the Hovermap really doing this, but of course I would assume the technology has to be adapted. Is this in the plan?
No, not currently. I mean, we often get asked, well, can Hovermap work underwater? The underlying algorithms would work in terms of the SLAM capability and autonomy. The LiDAR itself doesn't work. So the wavelength of LiDAR that's used just gets absorbed by water. So it's not going to penetrate through water. You do get other LiDAR that can penetrate water, but those LiDARs are typically not eye safe. So you've got to be very careful about how you're using them. And again, the sensing range can be limited with LiDAR underwater if there's sort of particles in the water and it's turbid.
Yes.
Obviously, underwater you can use other sensing devices like sonar. And in theory, yes, the data from sonar, if it has the right characteristics in terms of the resolution, etc., you could use SLAM on that. It's not something we've ever done, but in theory, it's possible. So yeah, I mean, it's not totally off the cards, but it's not on our current roadmap. It's a very challenging environment, as you know. I think flying a drone is hard, but I think underwater is probably even harder, especially when you get to depth.
Yes, I definitely agree. I've actually been exploring many sort of a deep sea, not even deep sea, but sea exploration companies. Yes, it is definitely quite a challenge. But thank you very much for giving us this insight. I was very curious to know, this position of Emesent. Now, I believe that we are finding ourselves the end of this interview, which I have to say, almost 40, 50 minutes of talk. It's amazing. It's been really insightful. We're not done yet. I have a couple more last questions for you over here.
Yep.
Now, first of all, regarding Emesent, right? What can we expect later on from Emesent? Do you have any products or maybe any super hyped innovations coming out that you're particularly excited about that you want to share?
Yeah, I mean, obviously I can't give away too much of the roadmap, but some of the stuff we're working on, like I said, is the spot autonomy, and that's still proof of concept stage. So we're doing early adopter trials, etc. But that will be commercialized. Focusing on one particular use case in mining to start with, and a few in sort of public safety. We're also kind of moving further up the value chain in terms of the data processing side of things and analytics. So, I mean, currently what our software produces is a point cloud, and then usually that point cloud would be taken into a third-party bit of software to do the analytics, taking measurements, looking for changes, etc. So we are building more of that capability into our desktop software, Aura. So currently, Aura is a really awesome tool. It runs the SLAM, so all the SLAM engines run in Aura, and then it's a very powerful point cloud visualization tool. We can handle massive point clouds to view them and sort of gain insights. And we can do some basic cleanup and measurements, etc. But now we're building more kind of analytics into Aura. One common workflow is just to compare scans over time and look for changes. So that's used across many industries to see what's changed. So that's the type of thing we're building into Aura, and a few other workflows specifically to certain verticals. Hardware size, we'll keep iterating and improving. I mean, obviously we're at the mercy of LiDAR sensors on the market. We're not building our own LiDAR, so we're always on the lookout to see what the latest LiDAR sensors are and how we can incorporate that into our products. And then the other integrations with other players in the ecosystem from a from a platform perspective, like other drones, other vehicles, etc. And from a software perspective, like I said, we're part of a value chain, so we're making sure we're integrating
Yes.
with those other sort of software vendors in the value chain. Yeah, so I'd say some pretty and some other very exciting things coming, which I mean I can't talk about everything, but yeah,
I understand. Completely understand, but thank you very much for that. And I know that I didn't really touch a lot about the part of the software or your long range radio. I know, but I mean, time was limited, and I believe that we got to know the Hovermap really, really good. I personally, I declare myself a fan. It is amazing how much use you have actually verged into this. Um, I want to jump into the final question that I have for you. If you have ever watched another episode of ours, you might know what is coming. If not, let me give you the question itself. You're a CEO,
yep.
but also you are an engineer at heart, right? So at heart and at career, of course, but you have sort of this vision of on both of those worlds. So what advice do you have for any young entrepreneurs, any young people maybe starting their own company or starting their own career in engineering? What advice would you give to these young people?
Geez, no, it's a great question. I guess I mean a very important thing is perseverance, because there's going to be challenges along the way, no doubt. There always will be. But I think if you're doing something that you're passionate about, not just about kind of the technology, but potentially
Right.
about how it can have an impact in the world in the future, that's for me, it's helped drive me. Like, how's this technology? If I look back in 10, 20 years time and, you know, kids, grandkids, whatever, and I explain to them sort of how we helped shape different parts of the world, talking about mining
Right.
and other industries, and say, well, this is how things used to be done. You know, there was no concept of drones underground, for example. You know, had people in these dangerous places, and now it's kind
Yes.
of, it's an industry standard. It's the norm. That kind of, yeah, it gives me the drive to keep going and persevere when we've got challenges. And I think the exciting thing for sort of people going through sort of studying now and seeing the future, there's just so many careers that probably don't even exist yet that there are going to be new opportunities for. So I think just being open to all these new opportunities, new sort of technology that is going to shape things and make things different. I mean, we haven't even talked about, obviously, generative AI and ChatGPT. Like, how's that going to
Yes.
change the world of robotics and every other industry? So I think sort of keep an eye or open mind into how those things could shape your career and what different careers there could be. And I think, you know, these days it's very common to change paths and careers
Right.
and sort of explore things along the way. So what else? Yeah, just stick to it, stick to your passion. I mean, I didn't have a direct path. Yeah, I tried a few different things, and I've ended up in an area that I love and I'm passionate about. And yeah, there's nothing better than having that. So sort of excited to be at work every day and doing cool things.
Thank you very much for that answer. It is not just insightful, but it's very inspiring. Thank you very much. I always love asking this question to our guests. It is probably one of the most insightful answers we always get. So thank you. Thank you very much for that. I believe that is the perfect way to give a closure to this, to this interview, where we have learned a lot. I personally learned not just about, your technology and LiDAR and SLAM and everything, but also, I mean, the use cases, I believe, is a very exciting area to learn about. I really recommend going and looking at your website, which leads me to the last question. Where can we find you? Where can we find Emesent? What are your social media handles?
Yeah, I mean, website's a good place. So that's emesent.com. LinkedIn is probably the most social that we're active on. So check out our LinkedIn page. We do often post, obviously, all kinds of things there. When I get a chance, I like to post as well, interesting point clouds and use cases. And then on the website, we have a bunch of different case studies. Some of them are firewalls, so you've got to enter details, but there's a lot of sort of other material that you can get without having to leave any details. But yeah, have a look around. There's a little bit of on other socials, but LinkedIn is definitely the best place to go.
Sounds good. And of course, we can find, out of LinkedIn, we can find everything else for Emesent. So thank you very much for sharing that. Now, everybody else, please remember, you can find more information, interesting articles, and a lot more interviews directly on our website, buildernation.io. We're going to love to hear from you. Stefan, this was an amazing interview. Thank you very much for being part of this community, for bringing your positive energy and bringing your insights and your knowledge. It was an amazing episode. We're gonna see you in the next. Thank you, Stefan.
Thanks so much, Sam. No, it's been a pleasure, and yeah, I can't believe an hour's flown by. It's been good fun for me as well. So thank you very much.
Appreciate it a lot. Thank you very much. Thank you very much, everybody else. We're gonna see you in the next. Goodbye.
Ciao.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic three-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.